Conditional probability. What if we're told the probability of something, given that something else has already occurred? Let's look at this example. The Venn diagram shows the number of people who liked tea and the number of people who liked coffee. A person is selected at random. What is the probability that they like coffee? This is simple as always, right? First, we want to add up how many people there are in total. So 47 plus 8 plus 49 plus 27 gives us a total of, let me just plug that into my calculator, 131 different people who are interviewed. Okay, so we can just put 1 through 1 on both of those. Yeah, so what is the probability that they like coffee? Well, you know that the number of people who like coffee are in this circle here, right? So that's just going to be 8 plus 49, which gives me 57 over 131. Okay? The probability that they only like tea, well, from this diagram, we know that this number represents people who only like tea. So we just put 47 there. 47 over 31, or 1 through 1, rather. What about if a person who selects tea is selected? So this is what we're talking about. Given that this person likes tea, right? So we're only focusing on this circle here. What's the probability that they like coffee? Well, how many people like tea? The number of tea drinkers is equal to 47 plus 8, which is equal to 55, right? Because there's 55 different people to choose from, isn't there? And the number of people who like coffee out of the people who like tea is 8. So the answer is 8 over 55. And likewise, out of all the people who only like tea, very important, they only like tea, right? The probability that they only like tea out of the people who drink tea is going to be 47 out of 55. Because there's only 55 people to choose from, isn't there? And so that is, hopefully gives you an insight of the probability of A given B. Does this video make sense? Make sure you subscribe so you never miss a video from me. We can also do this with two-way tables. The table shows the types of paper available for a giveaway. Complete the table. Well, we know that this plus this is equal to this. So 43 plus 54 is equal to 97. We know that this plus this is equal to this. So 36 plus 56 is equal to 92. Let's add all that up. So 43 plus 37 plus 56, that's just going to be 136. 54 plus 53 plus 36, that's just going to be 143. Let's add the two together. So 136 plus 143, that's just going to be 279. And if we do it the other way around, we get 97 plus 90 plus 92. That's also equal to 279. Okay? So now, what is the probability that it's lined paper? Right? The probability of lined paper is simply going to be the probability of, well, the number of lined paper is 136, and the total is 279. Okay? Now, given that it's unlined paper, so it's unlined paper, what's the probability that it's in the binder? So, for this one, we only have 143 to pick from, so it has to be over 143. Okay? And we know that the number of unlined paper in a binder is going to be 53. So the probability is going to be 53 over 143. Okay? Likewise, we can do this for these two examples. What's the probability that it's in a notebook? Right? The probability that it's in a notebook is we have to choose from all 279, so it's going to be 279, right? And if it's in a notebook, we know that there are 92 in total in a notebook. So the probability is 92 over 279. Now, important, given that it's in a journal, it is in a journal, this is a fact, right? What is the probability that it's lined? So this is all we're looking at. That's in a journal. How many journals are there? There are 97, okay? And out of all 97 of them, 43 are lined. So the probability is going to be 43 over 97. Do you guys need help with this question? Well, join my Discord server and ask me whatever the hell you want. For fast responses, guaranteed. We can also do this with probability trees. This is admittedly an A-level question, but we can still use the same process. Here we have P and Q as our probabilities. P and Q, okay? This represents Andrew's journey to work each day. This is whether or not it rained, and this is whether or not he walked, bussed, or cycled. Given that the probability of B is 0.26, find the probability of P. Notice this before, right? We're using the probability of C, coffee, given T, right? And what did we do? We did 8 divided by 55, because that's the probability of T intersection C and the probability of just T, because T has already happened, right? And we're using the same formula in this case. We're told the probability of B is 0.26, which means everything that happens to B, we need to work out. If this is P, what is this? This is going to be 1 minus P, isn't it? If this is 0.4, this is going to be 0.6. And if this is Q and this is 0.15, this is going to be 0.85 minus Q. Okay? First things first, let's put the probability tree up. Now let's work out all the different ways that we can get B. The probability of B is going to be P times 0.4 plus 1 minus P times 0.15. Okay? And we're told that this is equal to 0.26. Now, let's work that out, because all we're doing is we're just going like this. Yeah? So now let's work out the probabilities. So we can solve this like an equation now. 0.4p is equal to, 0.4p plus 0.15 minus 0.15p is equal to 0.26, which means that 0.25p is equal to 0.11, and so therefore p is equal to 0.44. So that's part 1 done. Now here's the hard part. The probability of not raining, given that he walked, is 0.175. So find the value of Q. Remember the formula that we have before. The probability of not raining given walking is equal to the probability that he didn't rain and intersection walk over the probability that it rained. Okay? So, the total probability that it rained, right? That's just going to be 1 minus P plus, times Q, right? That's going this way. And we're adding on to the end P times 0.6, okay? And the probability of not raining given that he walked is just going to be 1 minus P times Q, okay? Now all we need to do is work out what Q is. We know what P is. P is 0.4, right? So we can say 0.44. So we can say that 0.56 Q is equal to 0.56 Q plus 0. What is 0.44 times 0.6? It's going to be 264, okay? And we're told this is all equal to 0.175. And so now we just solve it like an equation. 0.56 Q is equal to 0.175 times 0.56 Q plus 0.264. Okay? Running a bit low on space, but that's fine. I'm going to put this up here for a second. I'm going to expand that bracket. So, just going to say, I'm just going to put it in fractions. 49 over 500 Q plus, and this is the important one, 231 over 5K is equal to 0.56 Q. So now we can put the Q on the other side. So we're told now that 231 over 500 Q is equal to 231 over 5,000. And so therefore Q has to be equal to 0.1. Okay? So now we know what Q is. Q is 0.1. This is 0.15, which means this, let's just rewrite the numbers. This is going to be 0.75, and this is going to be 0.44, 0.56. Okay? Now we can find the probability that Andrew cycles to work. The only way that Andrew cycles to work is if we go through this route. So the probability of cycling is going to be 0.56 times 0.75, which is equal to 0.42. Okay? And now, here's the part which is a bit challenging. Given that Andrew did not cycle to work on Friday, find the probability that it was raining on Friday. Well, all we're going to do is use this formula again, but this time, right, I'll do it in a different color. We're told that the probability that, what we're asked to find, the probability that it rains, given that he doesn't cycle, that's just going to be the probability that he rains over the probability that he doesn't cycle. Okay? The probability that he doesn't cycle, right? That's just going to be 1 minus 0.42. And the probability of rain is 0.44. So therefore the probability of him raining, given that he doesn't cycle, is going to be 0.44 over 0.58, which is equal to 22 over 29. And that is your final answer. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me. Drop me an email and you can organise a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.